Hello everyone, it's me Sanjay Vasu back again for another video. This is part 2 of a two-part video series on the Cambridge Primary Checkpoint Science Paper 1, October 2023. In this part, I'll be going through questions 6 through 13. Let's start. Question 6. This question is about the properties of gases. Look at the table that shows some properties of 4 gases. These 4 are carbon dioxide, chlorine, nitrogen, and oxygen. The color and odor of all the gases are shown. A. Write down 2 other properties of all gases. So 2 properties are the color and odor of the gas. The other 2 are that they have an extremely light mass. Actually, a better word would be low mass. And the second is that they are easy to compress. For example, let's say you just clap your hands, right? You're basically compressing gas. B. Blessy thinks that all gases are colorless. Explain why Blessy is not correct. Use information from the table in your answer. We can see that chlorine has a gas color of pale green. This is not colorless, right? Therefore, we can clearly see that Blessy's prediction or Blessy's thoughts are not correct. We can write chlorine is a gas which has a green color. And this is not colorless. Question 7. Mia has 2 electrical circuits. Both circuits have identical components. Complete the sentences. The parallel circuit is electrical circuit dash. We can see that for this circuit here, we have a battery, we have a switch, and then we have 2 lanes of electrical wires, each of them connecting to a different light bulb. So we can see that this is the parallel circuit. If you want an even easier explanation, these 2 lines are parallel, right? The coil wire lines. And then the circuit with the brightest lamps is electrical circuit dash. Well, a circuit which has only one light in one wire will obviously have these 2 lamps brighter than 2 lights in one wire, right? Since the power has to be divided equally between these 2. For these 2, the power can be completely passed through to both. So the answer is B again. Question 8. The diagram shows the order of the planets in the solar system. A. Look at the diagram. Draw the orbit of Earth's moon on the diagram. We can see that Earth is the 3rd planet, which is 1, 2, 3. This is Earth. And the orbit of the moon is going to be around the Earth, just like this. That's the answer for part A. Now for part B, are the names of 2 planets further from the Sun than Saturn. We can see that Saturn is a planet which has a lot of rings, 6th planet from the Sun. The 2 planets which are further are Uranus and Neptune. And we can write their names, Uranus and Neptune. That's the answer. Question 9. The diagram shows the human circulatory system. A. Organ X pumps blood through the circulatory system. Name organ X. Of course, it's the heart, right? The heart is the one that pumps blood all around the body. B. Blood vessel Y is a vein. Name one other type of blood vessel in the human circulatory system. There's 2 different answers. One is arteries, and the other one is capillaries. I'm writing arteries here, but if you want to write capillaries, this is the spelling right here. That's the answer. C. Which is the function of the human circulatory system? Tick one box. First of all, notice that they've written a function, not the function. So circulatory system does not just have the function of transporting blood around the body. There's also some more. For example, of course, it's not breaking down food, that's the digestive system. Control the body, nervous system, move the bones, skeletal system. Well, transport waste is actually done by the circulatory system as well. Even though the primary purpose is to pump blood around the body and pump oxygen along with it, transporting waste is also a very important function. The circulatory system is the one which transports waste to the urinary system. That's the answer. Question 10. This question is about melting and boiling point. A. Describe the change of state that happens at the melting point. Melting point, its definition, is the time when a substance changes from a solid to a liquid. That's the answer. B. What's meant by the words boiling point? The definition is quite similar to melting point, except it is the time when a substance changes its state from a liquid to a gas. The only difference between melting and boiling point is that melting is solid to liquid, boiling is liquid to gas. C. Ethanoic acid has a melting point of 17 degrees and a boiling point of 118 degrees. Room temperature is 25 degrees Celsius. Take one box to show if ethanoic acid is a solid, liquid, or gas at room temperature and explain your answer. Well, the answer is actually liquid. So, we can see that the melting point is 17 degrees. 25 is greater than 17, right? We can write that. 25 is greater than 17. So, the ethanoic acid has already melted, right? If the temperature is above the melting point, then it melted. If it's below the melting point, then it didn't melt. And then 25 is less than 118 degrees Celsius as well. We can see the boiling point is 118 degrees. If the temperature is at or above 118, we will have the ethanoic acid as a gas. But then now, since 25 is the temperature and that's less than 118, the ethanoic acid has not boiled or evaporated, and therefore it is a liquid. That's the answer. Question 11. A force diagram is a type of model. Look at the force diagram for a box. A. Which statements describe how this model helps students understand forces? We can see that there's a line and an arrow showing the direction of the force, and the box is the item. So the first one, forces cannot be seen. This is actually correct. Since, well, if you think about a force, you actually cannot see it. The only thing in this diagram is an arrow, but that only shows the direction of the force. It does not show exactly what the force is in living reality. And in living reality, there is nothing such as a force which can be seen. You can only see who is creating the force, what object the force is being applied to, but we cannot see the actual force. And our forces cannot be heard. That's false. If we clap our hands, we do a force, right? We exert a force from both sides on the hands. And this causes a sound. And that sound is technically created by the force, so it can be heard. The arrow shows the direction of a force. Of course, that's true. Since if the arrow is pointing this way, it goes towards that way. Arrow is pointing left, it goes left, the force. And the other three are all wrong as well. The arrow shows the type of force. This is wrong. We don't know what type of force it's using. Elastic force, buoyancy force, or what? What is propelling this box? We don't know. The length of the line shows the direction of a force. Well, the direction is showed by the arrow. The length of the line actually shows the quantity of the force, or how much force is being applied. It does not show the direction. The arrow does. Now the length of the line shows the type of the force. This is wrong. We cannot know what the type of the force is by the diagram unless there's specific things given. For example, if let's say there is a boat floating on water, it's probably buoyant force or buoyancy. That's because that's the only force that can apply to floating on water. Well, that's specific. This one is just a general one. We don't know which force is being applied. That's the answer. B. Look at the force diagram of the box. Complete the sentence about the movement of the box. The box moves to the right because we can see that the length of the arrow going towards the right is longer than that towards the left. So you can just write that. The arrow line is longer for the direction towards the right. That's the answer. Question 12. The table shows the percentage of the moon visible from the earth each night. So there's a table given here. A. Complete the line graph by plotting the last 4 points as small crosses and drawing a line through all the points. So you have the first 6 points plotted already. Now the 7 is 48%. That will be right here. The 8 or the 8th night is 60%, which is right here. 9th night is 70%. And 10th night is 80%. Now we can draw a small curved line through all of them. And you need to go through 0, 0 as well. By the way, I've drawn these as 2 separate lines, but you have to make sure this is just one. Since, as you can clearly see here, this line is straight. This line is steeper than this line, which is why it makes a bit of a rough bend there. But still, this is how it's supposed to look like. Usually you have to just draw it with one smooth motion like that. That's the answer. Question part B. Complete the sentence to describe the pattern. As the number of nights increases, the percentage of the moon visible from Earth increases. How do we say this? That's because, as you can see from the table and the graph, the number of nights increase as we go towards the right. The percentage increases as we move up. The graph moves both right and up at the same time when we draw through the line. And therefore, both of them increase. So this is the percentage of the moon visible from the earth, which is what we have to write here, that increases. Question 13. Mass and weight are different. A. Draw a line to match each description to its correct measurement. Description: mass of an apple. Well, mass of an apple obviously can't be 40 kilograms. Apples are usually measured in grams. That's why we draw a line to 100 grams. Weight of a book. Well, as we know, mass and weight are different. How are they different? The unit of weight is different. The main difference between mass and weight is that weight is measured in newtons and mass is measured in grams or kilograms or all those units which we know. So the weight of a book is not 40 kilograms. It can be, but that's only if it was the mass. The weight of a book is measured in newtons, 10 newtons. Now the mass of a chair is 40 kilograms. That's the last option left, but then it also makes sense since chairs are heavy, B. Complete the sentences. Choose words from the list. When gravity decreases, the mass dash. Well, gravity does not affect the mass at any time, so the mass stays the same. When gravity increases, the weight dash. There's a formula actually saying that the weight, as named as W, is equal to the mass times the force of gravity. And if the mass is constant and the gravity increases, then mass times gravitational force, that's the weight, that will also have to increase, right? So the weight increases. The mass is not determined by gravity. The mass, though, determines the weight. The gravity also determines the weight. That's why I wrote the formula which I just described. And that's the answer. That'll also be the last question which we have answered for the paper. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was and if you have any suggestions. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.